Alright, these are the final exam videos for Concept 8, solving equations. Each of these equations have different things you need to remember to solve them. So on part A, we have a quadratic. You can always check to see whether the quadratic is factorable. A times C and B. So if you start trying, there are no two numbers that multiply to positive 4 but add to negative 3. So scratch that, and then we could always use quadratic formula. So x equals negative b plus or minus square root of b squared minus 4ac over 2a. So that's 3 plus or minus 9. 4 times 2 is 8 times 2 is 16, so 9 minus 16 over 4. So that's negative 7. And when you have the square root of a negative number, square root of negative 1 is I, so that's going to come out outside of the radical, and 7 stays inside the radical. So we have 3 plus or minus I root 7 over 4. Alright, next equation here, we have a root, a square root. Let's get that root by itself first, so square root of x plus 9 equals x minus the 10 would give you negative 3. And then to get rid of a root, the inverse is to square it. So x plus 9 equals, if we square this side, don't make the mistake of doing this, x squared plus 9. This is not equal to this. We actually need to FOIL x minus 3 times x minus 3 if we're going to square it. So square this, square this. If we FOIL this, that's x squared minus 6x plus 9. So here the 9's cancel out, and then we have an x over here that we need to move over. So that's 0 equals x squared minus 7x. Factoring this, we can factor out a greatest common factor. Zero product property gives us that x equals 0 or x equals positive 7. Always make sure you go back and double check if any solution is extraneous. If we plug 0 in here, 10 plus 3 is 13. If we plug 0 here, 0 plus 7 is 7. That is not a valid solution because 13 is not equal to 7. Let's check this one. If we plug 7 in here, 10 plus square root of 16 is 4, so 14. Plug 7 here, 7 plus 7 is 14. And that works. So our only solution that's not extraneous is x equals positive 7. Alright, on part C we have a equation with fractions. So one way of doing this is first to add these fractions together. When you add fractions, you need a common denominator. So this fraction needs the x minus 12. This fraction needs the x in the denominator. So I'm going to multiply the bottom of this fraction by x, which means I need to multiply the top by x. The second fraction I need to multiply by x minus 12, which means I need to multiply the top by x minus 12. So rewriting that, we have a common denominator now, x times x minus 12. This is x squared. This is 6x minus 72, and we're adding those fractions together, equals 1. Now, in this case, we have a fraction on this side and we have a fraction on this side if we make that equal to 1. So I'm going to say that this times this, x squared plus 6x minus 72, equals this times this, x squared minus 12x. X squareds cancel out. If we solve this, this would be 18x equals 72, and x equals 4. Now, again, check for extraneous solutions, meaning plug the solution back in to the original problem, and we're specifically looking to see if the denominators end up equaling 0. Plugging 4 here does not make the denominator 0. Plugging 4 here doesn't make the denominator equal to 0. So x equals 4 is a valid solution.